All right, let's start on time so we can end on time. First of all, thanks for being here. I know, at least for me at NDC, there's always great talks, and I always have a difficult time choosing. So thanks for choosing this talk. And my name is Mete Atamel. I'm a developer advocate at Google, based here in London. And I'm going to be talking about serverless containers, Knative and Cloud Run, and how they can help for app modernization. There's a lot of things in one talk. If you've been paying attention, this talk was initially about Cloud Run. But then as I was thinking about it, I said, okay, well, Cloud Run is something that runs on Google Cloud. But if you're not on Google Cloud, what do? Well, you can use Knative, which is the open source foundation for Cloud Run. So that's when I decided to include that in the talk, because I think it's very relevant to people no matter where you run. And then recently, I also was refactoring and breaking an old monolith into a bunch of microservices, and I managed to make it work on Cloud Run. And that whole journey taught me a lot of things, even though it's a small app. So I decided to include that in the talk as well, so that we don't just talk about theory, but we also look at a kind of a real-world example and see what we can learn from the journey and how we can modernize your apps and use these technologies like Knative and Cloud Run to do that. So it's 3-minute talks within a talk, so you get 3 talks for the price of 1. But I haven't done this talk before, so I don't know the timings. I mean, my intention is that I will do 20 minutes, 20 minutes, 20 minutes with Knative, Cloud Run, and app modernization. But we'll see how it goes, and I might skip some parts if I'm running short on time. All right? And also, the deck is already on speaker deck. And the demos that I'm going to show for Knative and Cloud Run and app modernization, they're already on GitHub. I always like to publish my stuff before the talk. And I'm going to give you the links of those demos at the end of my talk. So you'll have everything that I showed today and more if you need it after the talk. All right, so let's first go through some intro, so we are all on the same page. And then after that, I'm going to go through Knative. Then after that, I'm going to go through Cloud Run, and then we'll look at the app modernization. And my talks usually go with a little bit of intro, a little bit of demo, a little bit of intro, a little bit of demo. So it's going to be back and forth. So hopefully, we'll keep things interesting. Now, have you heard of serverless enough in this conference? Yeah, I mean, every talk I've been to, there was some mention of serverless and some attempt of defining it. And I'm going to do the same here. But I think instead of defining serverless, I want to think of it in terms of 2 different models that you can think about it. First, you can think of it as an operational model, right? How do you run your code? And when you think about serverless way of running your code, you are probably thinking that there's no servers or there's like no infrastructure management that you have to worry about. I mean, of course, there are servers, but it's not your problem anymore. You're probably thinking that there's managed security, at least at the base level, that you can rely that things are secure. And of course, you need to do more. But at least the basics are there. And you only pay for what you use. And that's a very important point. And I'm going to come back to this as we explain Cloud Run and also my app as well. So that's kind of the operational model of thinking serverless. But at the same time, if you're an application developer like me, you're probably thinking in terms of services or microservices, if you want to call them, that are usually event-driven. So something triggers your function. This can be an HTTP call, or this can be a pop-up message or something else. And usually you're thinking of services that are stateless, because when you think of serverless, when your services are stateless, it's much easier to scale them, and it's much easier to work with them. Of course, there's ways to get state into your services, but in general, you talk about the services being stateless, and then you have the state somewhere else. So serverless is great because it kind of frees us from all the things that we had to do that's not part of our application. But at the same time, you are kind of limited on the service that you're using. So if you're using Lambda or Google Cloud Functions or Azure Functions, you are limited with their runtimes, right? So you can iterate fast, but you're limited. On the other hand, we have these things called containers. Containers, as you all know, it's a packaging format. And it allows you to package your app and its dependencies in a consistent way. And it also allows you to run that container in a consistent way in multiple environments. And the good thing about containers is that it gives you a lot of flexibility. So you can use any language, any library, and you have all this ecosystem around containers. So you have the container base images. You have projects like Kubernetes and Istio and Knative and others around it. So that it's a good place to be if you need that flexibility with your app. So far, this doesn't render properly on the screen, but I have these bubbles around them. But anyway, so far you had to choose between the two, right? You can either go with serverless and iterate fast because you don't have to worry about a lot of things. But then at some point, that's not going to work for whatever reason. Maybe you want to use a certain library, or you need to do long-running tasks, and that's not allowed in the serverless framework. Then at that point, you probably fall over to containers. That gives you a lot of flexibility, but then you kind of lose the velocity that comes with serverless. So you have to make this choice upfront, and I don't think it's a good choice to make. Why not have both, right? And that's the whole point of Knative and Cloud Run. What these projects are trying to do is that they're trying to give you a framework so that you can still use containers, but you can also use them in a serverless way. And I will explain what I mean by that. So all the things that you expect from a serverless function, you can kind of expect them from a container running on Knative or Cloud Run. And Knative is the open source project that everything is based on. So I'll start talking about that first. And you can run it anywhere there's Kubernetes. So if you run Kubernetes on-prem, you can install Knative and run it. If you are running in the cloud on a managed Kubernetes cluster like GKE, Google Kubernetes Engine, you can still install Knative and run it. And then on the other end of the spectrum, there's something called Cloud Run, which is the managed version of Knative on Google Cloud. And it's fully managed, meaning that you don't have to worry about a cluster. You don't have to worry about anything. You just say, this is my container, deploy it, and it will do it for you. And then there's something called Cloud Run on Anthos that's somewhere in the middle that I won't talk too much about. But just to let you know, if you want to stay in Kubernetes ecosystem, but you still want to be in the cloud, you can do that in Cloud Run on Anthos. So there, you're still running on Kubernetes, in a Kubernetes cluster on Google Cloud, but you're installing Knative on top of that. So that's given to you, so you don't have to do as much work, but it's still Kubernetes. It's not fully managed. So let's start with Knative first. What is Knative? The official definition is that it's a Kubernetes-based open source building blocks for serverless. Who is using Kubernetes here? Anyone? A few people. So you know that Kubernetes is not easy to use. If anyone tells you Kubernetes is easy, don't believe them. If you want to deploy a container on Kubernetes, you need to do a lot of things. You need to, first of all, create your container, like Docker file. Then you need to create a pod deployment. Once you want to expose it, you need to create a Kubernetes service. Then you need to worry about ingresses. And then if you want to use service mesh, you have Istio. Then you need to worry about virtual services, gateways, destination rules, all that kind of stuff. So it's not that easy. So that's why like Kubernetes and serverless, they don't really come together usually. But the whole point of Knative is that it tries to turn Kubernetes into a serverless platform, right? It tries to give you the building blocks for that. It's an open source project on GitHub. It started by Google, but now companies like VMware, Red Hat, and others, they're contributing to it. And the Knative and Cloud Run stack kind of looks like this. At the bottom layer, you have Kubernetes. Then on top of that, you have to install a gateway. Because Knative, it doesn't try to solve the problem of how to get traffic to your container. Instead, it relies on a gateway for that. You usually use Istio for that, but if you want to install other gateways, it's pluggable. And the last time I checked, these were the 3 gateways that were available. Then on top of that, you install Knative. Knative has 2 parts, serving and eventing. And I'll talk about what they are shortly. And then at this point, you can start using Kubernetes as if it's a serverless platform anywhere you run Kubernetes. But if you're on Google Cloud, then there's Cloud Run, the managed version, or Cloud Run on Anthos, the semi-managed version you can use as well. I should also point out that the fully managed Cloud Run, it's not based on Kubernetes. It runs on Google's infrastructure. So this picture is a little bit misleading in that sense. But Cloud Run on Anthos runs on Kubernetes. So everything else runs on Kubernetes. So first, I want to show you this part as if you're installing it yourself. Then we'll get into Cloud Run and show you what the difference is there. So what is Knative serving? This first part of Knative. It's a way to deploy containers in a serverless way. That's how I explain to people. What it does is that you create a Knative service, and you point to your container, and then you just say, deploy this container for me. And Knative deploys your container. It sets up the traffic to your container, so all the traffic is set up for you. Then it gives you automatic scaling. So by default, your container will scale up and down. Then it gives you configuration and revision management, meaning every time you deploy your container, you get a new revision, and you can use that revision from then on, or you can go back to a previous revision if you want. And then it gives you traffic splitting, right? So once you have multiple revisions, you can split traffic between them, right? So in a nutshell, this is what Knative serving does. And the terminology of Knative serving goes like this. At the top level, you have the service. This is a Kubernetes. This is a Knative service. It's not a Kubernetes service, so it's different. It's a higher level service than Kubernetes. So you create the Knative service that has a configuration. In the configuration, you usually point to the container and you pass in some environment variables and other things. And then once you deploy your service with the configuration, you get a new revision and you get the route pointed to the revision. And all this is done for you automatically. Every time you change something about the configuration, that creates a new revision and the route gets updated to that revision, right? So that's done automatically as well. And as I mentioned, once you have multiple revisions, you can set rules here and you can do things like A/B testing or you can do traffic splitting, stuff like that. So let's just take a quick look on how this works. As I mentioned, on GitHub, I have all of this available. So let's just take a look at one of them. So I have this Knative tutorial that I'm going to share the link with you. And in this tutorial, I show how to set up a cluster in Google Cloud and how to install Knative on top. One thing that I want to show you in setup is that I just want to go through the steps quickly so you get an understanding. I have all of these in scripts. So the first step is to get a Kubernetes cluster. Depending on which cloud you are running or whether you're running on-prem, you will have a different way of getting a cluster. This one uses gcloud to create a cluster in Google Cloud. Then you need to install a gateway. In this case, I'm using Istio as my gateway. And you need to set a local gateway on Istio so that you can use a Knative eventing within your cluster. So I do that in this script. Then you can install Knative serving and then Knative eventing. They are separate, so you can install one or the other, or you can install both at the same time if you want. And then if you want to use Google Cloud Events, there's another project called Knative GCP project. You can install that as well, and this will give you a way to read events from Google Cloud into your Knative cluster. So I do that as well, because I'm going to read PubSub messages from Google Cloud later. So I won't go through the scripts too much, but I just want to let you know that they're there. And if you just look at one of them, install serving. So this installs Knative serving, and you can see that all I'm doing is I'm just applying some YAML files, serving YAML, CRDs, and then I actually installed the serving YAML after that. And there's also some monitoring pods that you can install to monitor your Knative installation if you want. So you're basically pointing to the version of Knative you want. In this case, the version I'm using is 0.12, which is the latest as of today. And I'm just pointing to a YAML file, and then you will have Knative running. So once you have this, and I already did this before, here I am in Google Cloud. There's Kubernetes engine. I have my Knative cluster running. I just want to make sure that everything is running. So Knative serving gets installed under a separate namespace. It's Knative-serving. So I just want to take a look at the pods that in there. You can see that they're running, so everything is good. And let's take a look at Knative eventing as well. They're running as well. So Knative, it's just another application on top of your Kubernetes. And then if you look at kubectl get pods, Istio system, you will see that Istio is already there as well with Istio ingress gateway and cluster local gateway and things like that. All right, so what I need to do to deploy an app on a container on Knative, let's go through that. So I'm just going to go through a very simple example. Let's say you have this Hello World application that basically, when it gets a request, it will just say Hello World. And I do something more than that. Let me just show you the code quickly. This is C#, but I also wrote it in Python. And what we have here is, so first I am looking for a port environment variable. And if it's there, I bind to that. If not, then I bind to 8080. This is the contract for Knative and also contract for Cloud Run. And then this is it here. And then in startup, I look at HTTP GET. And once I get a request, I look at an environment variable called target. And if it's there, I will use it. If not, I'll just say world. And then in the response, I just say hello world or hello target if it's set, right? It's something very simple, but it's on purpose so that I can show you how this works in a simple way. So we build the app, then we create a Docker file out of that. And then we build the Docker, and we push it to Docker Hub, so the image is there. And then I need to create a Knative service. The way to create the service is like this. You create a YAML file. As in everything else in Kubernetes, you need to create a YAML file. This is a Knative service. I know this because I'm using Knative API, and the kind is a service. This is the name. This is the namespace that it gets installed. And this is the configuration of my service. In the configuration, you can see that I am pointing to my image, and I'm also passing an environment variable called target with the value v1, right? So that's the whole definition of my service. Compare this to Kubernetes. This is much shorter. In Kubernetes, you would need like multiple YAML files, and you would need to set up Istio with the right way. So compared to that, this is much simpler. And then to create the service, we just apply it. So let's actually do that. So first, before I do this, let me go to watch. So I'm watching some pods, Knative service, Knative configuration, revision, and route. So right now, I have 3 pods running. These are pods that I need for Knative eventing. Just ignore them, act like they don't exist, because I wanted to set them up before the talk. But to deploy my service, let's say kubectl apply service v1. And now this says the service is created, and you can see that immediately Knative creates a Knative service, and it creates a service for the it creates a configuration for the service. It creates the first revision of the service, and we cannot see it here, but it also creates a route for the service. Let me actually make this a little bit bigger. Yeah, we have the route as well, and then we also see that we have a pod running for our service. And if I do a curl, you will see that, hopefully, yeah, hello v1. So it's very exciting, but this basically tells us that the service is up and running, the routing is set up, and all that kind of stuff. Now, if I do any kind of change to my service, so let's go here. By the way, you can set up your own domain for this. For now, I'm using nip.io as my dummy domain, but you can actually set up a proper domain for it. As I mentioned, anything that changes in the configuration, it creates a new revision. For example, if we go to our service and we just change this environment variable from v1 to v2, we are making a configuration change, so that will generate a new revision. Similarly, if we go to our code and just change our code from hello to bye, this will be a code change. And what we need to do is we need to build our Docker image again and push it. And then we can go to the image and change from the image from version 1 to version 3. This would be another configuration change. And once we apply it, we'll get a new revision. So let's do this and see what happens. And maybe I will make this a little bit smaller. And keep watching. By the way, you can see that the pod is terminating because we haven't used version 1 for 60 seconds, so it's scaling down. So auto-scale is already set up for me. Now let's deploy another one, service v2. So this is the one with the configuration change. You will see that immediately it created a second revision for my service, and then it's going to create the pods for it as well. And then it will update the route to point to that pod. For some reason, yeah, did it create a pod? Was it too quick, or did it not happen? Let's see. If you do a crawl again, you see that it's hello v2. So we did a configuration change, and it's already getting all the traffic. Now, if we do a code change and push our image and want to deploy that image, you can just apply it, and then you will see that another revision is being created. This is generation 3, and then now we have 2 sets of pods running, one for version 2 and one for version 3. And if we do a curl again, we see that the code is updated as well. Now, of course, in the real world, you don't update code like this. What you should do is that you would make a code change, you will deploy a version of that change in a separate URL, you would test it out, make sure that it works, and then once everything is good, you would gradually send traffic to it, right? So you want to do some kind of blue-green deployment or traffic splitting or whatever you want to call it, and that becomes really easy with Knative. So let me show you a quick example of that before we move on to Knative eventing. So in traffic splitting, first of all, what you can do is that right now, all our revisions, they have random names, right? When you look at our revision names here, they are random names. But in traffic splitting, it makes sense to have proper names for your revisions, and you can do that. You can go to your service, and then under here, you can say, I want this service to have a stable revision name, and in this case, we are calling it hello world-v1. And then I'm also defining some traffic rules. In this case, I'm saying that I want this revision, version 1, to get all of the traffic, Anything after that, I don't want it to get any traffic, right? So once we do this, let's see what happens. Service v1, I think I call this pinned. So it's configured. You can see that the revision name now it's a proper name. And if we do a curl again, we are back to version 1. Now let's deploy another version. In this case, let's call it version 4. But let's keep the traffic rules the same. So we are deploying it, but we are still sending all the traffic to version 1. So let's do that. Now you'll see that another version, well, we can't see it now because I don't have enough space here, but another version has been created, I hope. Yeah, it should be, yes, version 4. And then if we do a curl again to the default URL, it still says v1. So version 4 has been deployed, but the main URL hasn't changed yet. And actually, if I go back to the URL and add latest dash here, I can get to version 4. Now it's scaling up. Now it says hello version 4, so it's running, but the main URL points to the version 1. So that's how you can do silent deploys and make sure that your new version works. And then once you are confident that it works, you can gradually start sending traffic to it. So you can go back to your traffic rules and say, okay, I want to change my traffic rules, and I want version 1 to get 50% of the traffic, and version 4 to get the other 50%, and anything else, I don't want it to get any traffic, right? So if we apply that, 50-50, you will see that nothing changed here. We didn't create any new revisions. We are just updating the route, so there's nothing new here. But if I do curl to the main URL, you see hello v4, next one, v4. At some point, it should say v1. I think something is, yeah, v1, yeah. It was maybe scaling up. But roughly, it should say half of the time v1 and the other half v4. Okay? And then if I am done with my service, I can easily say delete my service, hello world, and then everything about the service will just go away and the pods will terminate and we are back to where we were before. So that's Knative serving in a nutshell. The next part of Knative is eventing. And Knative eventing is all about pulling in events and passing them to your services, right? And these events can be events from your own cluster that you generate within your cluster, or it can be events that you listen from external sources. Now, I should also mention that the service can be a Knative service, or it can be a Kubernetes service. So you get to choose which kind of service you can pass the messages to. So in the eventing, the main building blocks are like this. First, you have some sources that are listening for some events from externally, whatever you want to listen. So you need to install them separately. And then you need to inject a broker into your namespace. So typically, you will have a single broker into your namespace that will listen for messages coming in from the sources. And then once you have the broker receiving the messages for the namespace, then within the namespace, the services, Kubernetes or Knative services, they will decide what they're interested in through triggers. So in this trigger, this service wants to get all the red messages, and in this trigger, this service wants to get all blue messages, right? So that's kind of like the building blocks of eventing. The kind of event sources that's already there is this. This is not the full list, just some of them. So you can listen Kafka messages, you can listen Google Cloud PubSub messages, you can listen Kubernetes events, Google Cloud Storage, and more. So there's many more sources there. And you can also write your own source if you want and listen things in your own system. And then I should also mention that all sorts of different events come into Knative, but they eventually get converted into what's called cloud events. It's a common eventing format that was designed by CNCF, so it's an open source eventing implementation. So all these events will be converted into that, and the data part of that cloud event will actually include the payload. So if it's a GitHub event, you'll find it in the data, and the broker will get that kind of event. So let me show you a quick example of this before we move on to Cloud Run. So in this case, what I'm doing is that what I want to do is that I want to connect cloud storage events to Cloud Vision API. So I want users to be able to send pictures, save pictures into cloud storage. And once a picture is saved, that storage will trigger an event to PubSub. You can set it so that it triggers a message to Google Cloud PubSub, which is an event bus. And then I will read that message into Knative using Knative eventing. And then from Knative eventing, I will pass it to a Kubernetes service, actually, not Knative service, but it can be a Knative service. And then I will make a call to Vision API and extract labels from that image using machine learning, right? So what I'm doing here is that basically when an image is saved, an event is triggered, and that event will make a call to Vision API, and Vision API will label this image for us and tell us what this image is about. So now to do this, the main things that you need to do is, and I have other examples here, you can take a look later. The main thing that you need to do is, first of all, I'm reading Google Cloud Events, so I need to install Knative with GCP YAML, and I did that before. And I need to create a PubSub topic that I did that before as well. Then you need to create a source. Source is the thing that listens to external events, right? So in this case, I create what's called Cloud PubSub source. And in here, I point to the topic that I want to listen. So this is the Google Cloud PubSub topic that I'm listening. And then I also define my sync. So once I get this message, what should I do with it? You send it to the broker in the namespace, right? So you need to set this up. This is how you set it up, and I already did that. And then the broker lives in the namespace, so you need to label your namespace with the Knative event injection, right? So once I label my namespace, then a broker gets injected into my namespace, and it waits for messages for the namespace, right? So I did all this work. Let's just make sure that they're actually there. So if I do kubectl get cloud PubSub source, I should see that there's a PubSub source waiting for messages from external PubSub topic. And then if I do a get broker, I should see a broker in my namespace as well. Now I need to actually deploy my code, my service. So to do that, let's look at here. So I create my code in C# or Python. It's basically a code that when it gets an event, it makes a call to Vision API. I won't show it here because we don't have time, but you can take a look at it later if you want. I push my image. Then I create, in this case, a Kubernetes deployment. This is harder, as you can see. I need to create a deployment and a service. I do this just to show that you can do it with Kubernetes services as well. And then I create my service. Then I need to hook my service to the broker using a trigger. So in this case, I'm saying that, OK, I want to create a trigger. I'm not filtering any messages, so any message that comes into my broker will get to my service. And here I define who gets the service. So my subscriber, it's a Kubernetes service. But if it's a Knative service, you would just use this one instead of the other one, right? So let's do this. So I'm here. Let's apply service YAML. Then I created my my Kubernetes service. And then let's also create the trigger. And the trigger is created as well. And then if I do get trigger, you see that I have a trigger vision, and it's pointing to my vision service. And then if we look at now, if you look at our pods, we see that there's a vision pod. And if I look at the logs of this, and let's just follow it, you see that it's just waiting for something to happen. Now, to trigger this event, I will go to Google Cloud, go to Google Cloud Storage. Then there's Knative bucket, where I set up and initialize with notifications so that when I save a file, it sends a message. I will upload a file. And for this one, let's just upload my picture. Now, as this is uploading, it goes to the storage. This will trigger a message to PubSub, and then we'll read that message. And that will go to Knative eventing, and then from there, we'll get to our service. And if everything worked, you see that our service received the message. And from there, it extracted the URL or the image, and then it made a call to Vision API, and it says, OK, this picture is labeled forehead, chin, facial hair. So it's me. Yeah, so you can see that this is the sort of things that you can hook up together using Knative eventing. All right, we are already halfway done, so that means I need to speed up. But let me clean things up. So let's delete service, and then let's delete the trigger. And we're back to where we were. All right. All right, so that's Knative, and that works everywhere you have Kubernetes. Now, what is Cloud Run? Well, it's the same thing as Knative, right? It tries to bring serverless to containers. The idea is that you would deploy a container and get it in production in seconds with a URL that you can ping. The whole experience is kind of designed for being serverless, and I'll show you how this works. And also it's designed to be open, right? Like that's why Knative exists, because you can run it on-prem with Knative. But if you're in the cloud, and if you're okay with using Google Cloud, then Cloud Run is a much easier way of running it, and I want to show you how now. The basic use case for Cloud Run is basically public endpoints, kind of things like API endpoints or webhooks and stuff like that. But you can also use it for private endpoints. Let's say you have some private service and you want it to be only called by internal services. You can make it private so that not everyone can call it. Only people with certain headers can call it. There's some contract that you need to adhere to. So as in Knative, you need to listen on 000, and you need to listen on port environment variable. If it's there, you need to use that because it might change. Usually it defaults to port 8080. Your server needs to start. You can't just hang around for a long time. It needs to start within 4 minutes. The request time, so when you get a request, you need to respond in 15 minutes or less, right? So it's not good for long-running tasks. You can do small ETL jobs, but it's not for like long-running 1-hour tasks yet. I mean, in the future versions of Cloud Run, maybe we'll introduce that, but as of today, it's for short tasks and things that are stateless. You cannot have any state in Cloud Run except some memory, but even that goes away when the whole thing scales down. And the whole computation has to happen within the request, right? So when you get a request, you have to do the work in the request. You cannot just spin another thread and do things in the background. It won't be allowed because the whole thing is sandboxed by something called gvisor, and gvisor will kill your threads if you try to do that. And there's all these resources that you get. I won't bore you with the details, but basically you get 1 CPU per container with 256 megs of memory, so on and so forth. And I should also point out gvisor again. It's sandboxed by gvisor, so you can't do crazy things with your container. Otherwise, gvisor will kill it for you. And you can read more about gvisor. There's a separate project for that. And for me, the best part of Cloud Run is that you pay for what you use. So you specify what CPU you want, what memory you want, and how many requests you get. And you pay for 100 millisecond increments, right? So if no one uses your app, you don't pay anything, right? Or if it's an occasional connected app, it's perfect for that. And I'm going to talk about this later when I talk about our application. And the time that you get billed is actually not the instance time, right? So let's imagine that your container woke up and it's running, but you don't get any requests. You don't get charged for that, even though your instance is running. You get charged at the beginning of request 1 and at the end of your last request 2. So in that time, you get charged. But the rest of the time, even if your instance is running, you don't get billed. So this makes it really, really cheap compared to other places. And one thing to point out compared to other serverless platforms is that concurrency, you got concurrency here, right? Normally, if you're running on Lambda or Google Cloud Functions or any kind of serverless functions kind of framework, you get one request and that gets handled by one function, right? But in Knative, well, not Knative, in Cloud Run and also App Engine, you can handle multiple requests. And this is good for concurrency. All right, so let's show a little bit of this. So this was Knative tutorial. We don't need this anymore. And I have another one, Cloud Run tutorial. And in here, I talk about some use cases. So let's just go through some of them. Let's see how you deploy the same kind of Hello World app, but this time on Cloud Run, and look at the difference there. All right, so first, you create your service, your code. We did that before, so I won't show you that. Then you need to build your container and store it in Google Container Registry, which is an internal registry for Google Cloud projects. To do that, you can use gcloud. So when you say gcloud build submit and point to your project and tag your image, this basically takes your project and builds it in the cloud using something called Google Cloud Build. And then once it builds it in the cloud, it saves it into Google Container Registry. So this command does that. And let's double check that I already have it here. So if I look at Container Registry, these are all my images. But under Hello World, you should see there's a Hello World v1. So it's already there. I built it 3 days ago. Where are we? And then to deploy it, it's basically a single command. So you'll just say gcloud run deploy, your service name, the image that you want to deploy, the platform, in this case, is managed, meaning I want to use the managed version, the fully managed version of Cloud Run. And I'm also saying allow unauthenticated. So I want this to be a public service, right? So let's do this. Let me see, echo service name. Yeah, well, we don't have, oh. Let me see if I have it set up. No. So let's do service name, hello world public, and then do our G-Cloud run deploy. And then, if this works, now this is what it's trying to do is that it's deploying, it's creating a new revision, like we created a new revision Knative. It's setting up IAM policy, meaning anyone will access to it, and then it's routing traffic to it, right? So it's doing the same things that I show you with Knative, except the big difference is that I didn't have to create a cluster. I didn't have to set up Istio or Knative or all that kind of stuff. I just said deploy this container and everything is done for me. Now within a few seconds, you get a public URL, and if we actually go to Google Cloud, let's look at Cloud Run. You see all my Cloud Run services. Hello World Public is here. And then by default, you get some metrics. No one uses my app, which is sad, but you would see like the request latencies and CPU allocation, things like that here. Under revisions, I see all the different revisions on my service that's already deployed. So this one was just deployed now. And since we have multiple revisions, we can do traffic splitting if we want to. Then it has really nice integration with Stackdriver, which is the DevOps tool of Google Cloud. And under logs, I can see some basic logs on my application. You can see they're just listening on port 8080. And then if you look at the YAML file, you can see that it's regular Knative service, but it's fully managed. And then I already get a public URL, so I don't have to worry about setting up domain and stuff like that. And then it just says hello v1 just like before. But everything is set up for me. Now, if I want to change things, I can deploy a new version. I can do it from command line, but I can also do it from here. So I can change things like how much CPU is being allocated. I can increase the memory if I want up to 2 gig, stuff like that. And then I can set environment variables, right? So here I'm reading target version 1, but you can add more if you want. And then as soon as you deploy, it creates a new revision, and it will update traffic to that revision, right? So this is a public service. You can also do private services, as I mentioned. So let's just quickly look at that. So in private service, the difference is that you deploy the same way, but then you pass in this flag and you say, don't allow unauthenticated. I don't want everyone to call this. I only want certain people to call this. So once you deploy it like that, and I think I already have it. Let me show you an example. So let's go to Cloud Run. And hello world private, it's the same service, but now you can see that the URL is grayed out because I cannot get to it, right? I need to be authenticated by it, but the UI is quite nice that it basically tells me the curl command to run. So if I run this curl command and pass in this authorization header, where I grab an identity token, then I will be able to call this. So let's try it out. So if I do this, then hopefully I will be able to call my internal service. Yes, hello world. So you can see that calling internal services is also, deploying them in an internal way it's much easier. If you need to do this from your code, if you need to call it from your code, it's a little bit more complicated, and I show it in my tutorial, but it's quite straightforward once you understand it. So these are base use cases for Cloud Run, but then there are other use cases that you can also use Cloud Run with. For example, you can use PubSub trigger services. For example, if a message goes to a queue, then PubSub can make a call to your Cloud Run service, to an internal service. You can have storage triggered services. So if you save a file, then that notifies PubSub, and PubSub can call your Cloud Run service. You can have scheduled services. So there's something called Cloud Scheduler, which is kind of like cron, but for the cloud. And you can make Cloud Scheduler call Cloud Run on a certain schedule. So you can see that there's a lot of different ways of running Cloud Run. And the last one is an async task way of calling Cloud Run. So there's this thing called Cloud Tasks in Google Cloud, where if the user does something, you can capture what they did, like registration, for example, and you can push a task to a queue, and that task can trigger a Cloud Run. And the good thing about Cloud Tasks is that if something is wrong with the task, let's say your Cloud Run instance crashes, Cloud Task keeps track of the task and it retries and stuff like that. So it's actually very useful for things like that. To show you an example of this, I won't deploy, but I just want to show you how it looks. I deployed, well, maybe I show it here. I deployed a scheduled service, so a Cloud Run service that gets called on a schedule. And the steps for that is, first of all, you enable Cloud Scheduler in Google Cloud, and that's how you do it. Then you deploy your service. In this case, my service is called Event Displayer. So I just built my image, and then I deploy. But when I deploy, I am doing it an internal service, right? Because I don't want anyone to call my service. I only want Cloud Scheduler to call my service. So that's why I'm deploying it internally. Then to enable Cloud Scheduler to call my service, I need to set basically a service account. So I create a service account, and then I give that service account a role that says it's a run invoker. So it can make calls to Cloud Run services. That's what that means. Then, once I have that, I create a schedule. And in this schedule, I think this says 5 minutes. Every 5 minutes, make a call to this HTTP URL, which is the URL on my service. And then pass in this, this is my service account, and this is my token audience, which is the URL on my service, right? So that's how the scheduler can actually use the service account and make a call to your internal service, and everything just works. And you'll see in the logs that your service gets called every 5 minutes, right? So this is just an example. We have 20 minutes, which should be enough time to talk about somewhat of a real-world example of all of this. All right, so hopefully you understood the point of Knative and Cloud Run. Hopefully you also understood that Cloud Run is like really much easier way of running it if you are in the cloud already. And what I did is that me and my friend, Engin, who was here yesterday, but he couldn't come today, we worked on this app over the years, and I want to talk about the initial app and how we transformed it over the years, and how I actually used Cloud Run in the end to make it into in an architecture that kind of makes sense, and go through that story so that you have a concrete example of what it looks like. So this app, so me and my friend, we were both original from Cyprus. We like to read news from Cyprus. So what we tried to do is that we said, okay, why don't we build a mobile app where we kind of aggregate all the news from Cyprus in a nice, easy app. So that was our idea. So my friend, he worked on the mobile front end because I don't know anything about front end. And then I worked on the back end, right? So how do you get the RSS feeds, and how do you transform them, and how do you display them in a web API? So the initial prototype, and I think this happened late 2015 or early 2016, we had an ASP.NET app. This was, I think, 4.6, running on Windows only. And it was a single app, but in reality, it was 3 different things. The first one was reader. So the reader would basically, on a schedule, it would go to RSS feeds and just read them. Then there was a transformer that would get them and transform them into a common format. Because these RSS feeds, there was no standard, right? Like they were all in their own standards. And what we wanted to do is we want to extract the things that we wanted, like the news title, news body, news images, and stuff like that, and transform that into a common format. And then serve it on a web API so that the mobile front end can call it and get this, these RSS feeds in a common format, right? So we did this in a weekend or 2, and it kind of worked. So that was like the positive of it. It just worked. And it was really easy to deploy because a single app on a single machine, and by the way, we hosted on an IaaS hosting site, right? It wasn't even cloud or anything like that. And it was really cheap as well to host. It was like $1 or $2 per month or something like that. So it was very easy to get it up and running, but there was a lot of problems with it, right? First of all, the biggest problem was that it was 3 separate things, but we all bundled them together into one thing, and there was too much coupling. And you could see that in our code as well. Even though I list these as like reader, transformer, and web API, they weren't as neatly separated. When I was reading, I was also transforming. As I was transforming, I was writing somewhere else. I wasn't doing a good job because it was a prototype, but there was too much coupling. Then the developer experience of the IaaS host was horrible. Like, for example, it would go down once in a while, and it would be down, like the machine would be down for like 10 minutes, and we didn't know why. I would have to FTP to the IaaS host to see the logs. I couldn't see them easily, things like that. There was no redundancy. It was a single machine, so if it went down, everything went down. There was no persistent, everything was in memory because that's all we needed at the time. And there was no resilience whatsoever. So if the reader crashed for whatever reason, it would bring down the whole thing, right? So it kind of worked, but barely, right? So this was late 2015, early 2016. Now, in the next stage of the app, we said, okay, why don't we, and this was a time when I started working for Google and I was getting into cloud technologies and everything. I said, why don't we just lift and shift this app to the cloud and see what happens, right? It was more like an exercise to see how easy it would be to do that and what would we get out of it. So that's what I did. On Google Cloud, there's something called Compute Engine, which are basically virtual machines that can host Linux or Windows. So I took a Windows server and deployed the IIS app there. And it was actually quite easy to do that, right? Taking an existing app and deploying on a VM Windows server without any persistent is quite easy. So it just kind of worked. But to my surprise, we also got some benefits that we weren't expecting. For example, in Compute Engine, what you can do is once you deploy your app, you can take a snapshot of your app or your disk, and then you can tell Compute Engine, can you please create like 2 or 3 or 4 copies of this for me? And it would be really easy basically to have multiple VMs running if you need redundancy, right? And then once you have multiple instances, you can put them into instance groups, and then you can have a load balancer in front of it, right? So all of a sudden you have redundancy and you have load balancing without really having to do much work. All I had to do was basically just take the snapshot and just tell Compute Engine, just create an instance group for me. So that was nice. There was also the possibility of auto-scaling. I mean, I didn't set auto-scaling myself because we didn't need it, but it's very easy to set up auto-scaling in Compute Engine and just say, when you read this metric, auto-scale my Compute Engine instances. You can do that. I mean, you have to manually set it up, but having the possibility was nice. The DevX, the developer experience was much better than IIS hosting. All of a sudden, we could see our logs in Stackdriver. We could start and stop our VMs, stuff like that. And the only downside, I would say, is that compared to IIS hosting, cloud is expensive, right? There's no question about that. I mean, instead of paying like $5 per month or something like that, at this stage, we're probably paying more like $50, $60 per month because we were running a couple of VMs, we were using load balancer, we were paying for Windows server licenses, stuff like that, right? So it became a little bit more expensive than we expected for a smallish app, right? Now, the next stage of the app was, so just to let you know, this was roughly 2017, and you see that we didn't do anything for 2 years, right? Because once things are running, you don't want to like touch them, right? That's what happens, and that's what we did. And at the same time, I was also kind of waiting to see what happens with .NET Core, right? Because at the time, like, this .NET Core thing was just coming out, and it promised all these things, like it's going to run everywhere. And I was a little bit skeptical because I used to work at Microsoft, and I'm like, really? Like, they're really doing this? So I was kind of waiting to see what's going to happen. But then in early 2019, I was kind of like, okay, this .NET Core seems pretty cool. So why don't I try to rewrite this app in .NET Core so I can run it in everywhere, basically, not just on Windows. And I dedicated a weekend to rewrite the app in .NET Core because I wasn't sure what was going to work or not. And to my big surprise, it took me 2 or 3 hours to rewrite the whole app from .NET to .NET Core. And I was pleasantly surprised, and big props to Microsoft for doing such a good job with .NET Core. They really, I mean, some parts of our code, I didn't have to change anything. Some parts I had to change, but it was really easy to find documentation on what to change. And some parts in ASP.NET Core, it was just better, so I could just get rid of it and just use ASP.NET Core way of doing things. So it was really relatively straightforward. And then the next step was, I was encouraged by that. I said, okay, I have the rest of the weekend, what can I do? So I said, okay, why don't I containerize it? Because once you write your app and containerize it, it opens up so many doors, right? You can deploy it to so many different places. So I containerized it barely, like, because I didn't know Docker that well at the time, and I still don't know that well, because writing Docker files in an efficient way and a secure way is really difficult, actually. But I containerized it, and then at that point, I had all this choice where I can deploy it. I could deploy to Kubernetes on Google Kubernetes Engine, or I could go to App Engine Flex. And I went with App Engine Flex because in App Engine Flex, you basically say, here's my container, run it. And it does that on VMs. but the user experience, the developer experience is really easy. Here's my container, just deploy it. Whereas Kubernetes, even though it was more popular, and I could do it that way, but I had to do a lot of things like pods and services and all that kind of stuff that I didn't want to get into, to be honest. So I chose to deploy to App Engine, and then that gave me benefits as well. So first of all, I got rid of Windows, so things got cheaper. Secondly, in App Engine, there's load balancers and there's auto-scaling, but you don't have to do anything for it. You just say, deploy my container, and then all of a sudden you got load balancing, you got multiple versions, you get auto-scaling set up for you. So it's kind of like magic that it just happens behind the scenes, and you don't have to manually do it yourself. And we also got revision management, meaning every time I deploy my app, I get a new revision, just like I showed you in Knative. In App Engine, there is also the notion of revisions. And this made it really easy for me, because sometimes I would deploy something, it wouldn't work, but I can go back to the previous revision really easily. The only downsides I can think of in this case is that I'm still working on VMs, because even the App Engine kind of tries to hide the VMs, it was still VMs behind the scene. And this deployment was slow. It would take like 5 minutes, sometimes 10 minutes to deploy a simple app, and I didn't like that too much, but that was the reality, right? So how much time I have? Oh, 10 minutes. Okay, so the next update was mid-2019. As you can see, we're getting faster because we are using things that are modern and things are becoming easier to update. So in this update, after like a few months, I said, okay, a new version of ASP.NET came along, so 3.0, so let's update to that, and that was quite easy. And then, at the time, Cloud Run was being announced at Google Next in San Francisco. And I said, okay, why don't I just try to deploy this container to Cloud Run? And that was literally a single gcloud deploy command to deploy it. It was still a single app. It wasn't like microservices or anything like that. But I could run it on Cloud Run. And then all of a sudden, our bill dropped from like $20, $30 per month to like almost free. Well, I should say free, because there's a free tier in Cloud Run, so it was pretty much free, right? And the reason is that our app is not like the most popular app in the world, and it's occasionally connected, right? So sometimes when someone wants to read the news, that it comes and it wakes up, and then it gets the feeds and then it serves them, and then after a while no one uses it and it just shuts down. And that model is perfect for Cloud Run. It's perfect for occasional connected apps. So I was really happy about the serverless billing that made it free for us. The DevX of Cloud Run is really good, so you can deploy within seconds. So instead of like 10 minutes, we basically deploy like every second or so if you want to. And then this integrated logging that I show you, the revision management, all that kind of stuff really makes it much easier to work with. So these are the kind of the benefits that we get by just moving to Cloud Run. But the issue that we had was cold starts. So our app, if you remember, it's a reader, web API, and converter, right? And the reader, like when Cloud Run scales down, it doesn't read anything. It just dies. And then when a user comes to get the feeds, then we have to wake up first. So it has to start the container, which is pretty quick. But then the reader has to go fetch and then come back. So that was an issue that I wanted to fix in the next iteration. So the next update was literally like a couple weeks ago. And I said, okay, this app doesn't make sense anymore as a monolith, right? It needs to be broken down. And I wanted to go through that and see what it takes to actually break. I mean, even though it's not too complicated of an app, it was still somewhat complicated. See how we can break it down. So in the end, this is what we ended up having. So first, we created a reader service. This is a Cloud Run service that simply, it just fetches the feeds and then brings them back, right? Now, of course, this has to happen on a schedule. So I put a Cloud Scheduler in front of it. So Cloud Scheduler, maybe every half a day or every day, whatever you want, would call the reader and get the feeds. Then the reader has to save the feed somewhere, right? So to save it, I use Cloud Storage. So it just gets the JSON and saves it to Cloud Storage. And this is very easy to understand. It's very isolated from everything else. And I can also go to Cloud Storage and see my feeds and see how they are saved. Now, the second part is the users. So I created another Cloud Run service called Web. And this time, oh, by the way, the reader is a private service, and only Cloud Scheduler can call that. And the Web is a public service, and the users will call the Web to get the actual feeds in a common format. Now, of course, we have the feeds here. They're not transformed yet, so I need a transformer for that. So what you can do is you can set cloud storage to publish events when something happens. So when we save a feed, that can publish a message to PubSub, and then that will call another service called converter. It's a private service that will get the actual file, and it will do the conversion. It will basically look at the file and say, okay, this is a feed of this type, and I need to convert it into this format, and it just has all these rules to convert it. And once it converts it, it says into something called Firestore. So Firestore, it's a NoSQL database from Firebase that's part of Google Cloud. And it's very good for SQL type, JSON type objects. So it was a natural fit to do the conversion and save it to Firestore. And then the web would just talk to the Firestore, right? So as you can see, we went from one monolith to 3 separate microservices. And each microservice, they do their own thing. And it's kind of easy to kind of conceptualize them and see what's happening. And for me, the biggest advantage was that, first of all, the web only looks at Firestore, and we have persistence now. So there's no cold start issue anymore. Then reader only, if I want to know if the reader is working, I can just look at cloud storage and see if it's been updating. The converter only updates the Firestore, so I can just see when was the last time it updated the Firestore. So in every way, it seems better. But of course, with everything else, there's trade-offs, right? It's not always like the best solution. So the trade-offs are like something like this. First of all, the architecture is loosely coupled, so I can update each part as I want. I can update individual pieces, and for me, the piece that I always update is the converter, right? The rules change a lot with these RSS feeds, so I need to change the converter a lot, but I don't really need to change the way we read feeds, or I don't need to change the web UI that much. So this is the part that I'm changing a lot, and now I can do that without having to affect anything else. And we can use different languages, right? Right now I'm using C# everywhere, but there's no reason why the web UI cannot be Node.js or something like that. Being able to do that helps, because if someone else wants to take this app in the future, they can take and write in their own language. And yeah, better utilization of the resources, because the reader, it just wakes up once a day or so we are not wasting sources. And the web UI, it can scale without having to scale the reader, right? I mean, before it was stupid that we were scaling everything together when we only needed to scale the web part, actually. And the disadvantage is that there's many parts now. Like, it's not a one app anymore. Like, you have 3 different services. You have cloud storage, you have PubSub, you have Firestore. So it is more complicated. Like, no matter how you look at it, it's more complicated. And this is a decision that you need to make. I mean, for me, since I want to maintain this app, having this kind of infrastructure is okay. But maybe for your app, it's an overkill. So that's a decision that you need to make. And obviously, it's more expensive, because you need to pay 3 services, and storage, and PubSub, and Firestore. So I don't know, I didn't run the numbers, but it feels like this, I mean, with all the moving parts, it should be a little bit more expensive than having the monolith. Maybe it's similar, I don't know, I haven't done the math. So the lessons I learned here is that, first of all, you've seen the transformation. Even for a simple app, it's not that straightforward. You don't go from Windows, ASP.NET to a Cloud Run service just with one iteration. It has to be a transformation, and it has to be a little bit of gradual transformation as you go along. Taking the app and just putting it in the cloud, even that has a lot of benefit, as you've seen. Like, I wasn't expecting that I would be easily take an existing app and just put it in the cloud and get all the benefits that I wasn't really expecting. So it's something to think about. We had non-optimal solutions along the way. For example, App Engine wasn't the best place to basically deploy my app, because we didn't have Cloud Run. But these non-optimal solutions, since I got ready for App Engine Flex, since I containerized my app, it helped me to move to Cloud Run much easier. So even though things might be non-optimal for now, they're actually stepping stone for optimal solutions. You have to rewrite your code at some point, right? I had to literally go through my code, refactor it, and split it out into 3 different pieces. It just has to happen, because you are changing your environments from on-prem to the cloud. So at some point, you need to kind of take advantage of the cloud, make things pluggable, make sure you can replace things. So I had to change my in-memory from in-memory to Firestore. So I had to rewrite things and make things pluggable. But that's inevitable as you go from on-prem to the cloud. And finally, everyone talks about monolith and how great it is to decompose it, right? And it's true in some ways. but in other ways, it's very complicated. Even for a simple app like this, it takes a lot of time to figure out how to decompose it. Then once you decompose it, how do you deploy it? How do you communicate with microservices? There's a lot of decisions that you need to make. So it's going to be more complicated than what you have, no matter how you look at it. But you have to basically make a conscious decision and say, okay, is this worth it for my scenario? What am I trying to do? I mean, for me, it was good to separate it out so that I can actually look at these separately. And also, the fact that I just update converter and nothing else was worth it to go through this exercise, but you need to make that decision yourself. Unfortunately, we are out of time, and I can't take any questions, but thanks for listening. I'm going to be here after the talk, and I'm going to be outside as well, so if you have any questions, feel free to reach out. So the Knative tutorial is there, the Cloud Run tutorial is there, and these are the official links to the products. And then the app itself, we call it Amathus. It's an ancient city in Cyprus, so that's how we chose the name. If you want to take a look at it, it's there. I have instructions on how to deploy it if you want to deploy it yourself. I don't know, maybe you want your own news feed. Feel free to take it. And yeah, thanks for your attention. Thanks very much.